Hey guys, let's take a look at number 8 in Achieve section 7.5. This is one of those gorgeous partial fraction differentiation problems. Now, this one's not too bad though. We have a linear numerator of 9x plus 6, and all of our denominators are linear factors. Remember that first one, x squared, is just a repeated linear factor of x. So we say this is the scenario where all of our numerators are going to be constants when we break it apart, and for every one of the powers of that x squared we're going to have a separate linear numerator, or sorry, I should say constant numerator. So now when I break this apart and say, okay, partial fraction decomposition, this fraction is going to equal a over x plus b over x squared. Had that been an x cubed, I would need a plus c over x cubed. Since it was just x squared, I only needed two separate fractions for those. Now my third term, c over x minus 1 plus d over x minus 3. Okay, now from that we go into our problem and we can say, well, I can multiply by the least common denominator on both sides of my equation. When I do that on the left, I'll get 9x plus 6. When I do that on the right, this x is only going to cancel out one of these x's, and I would have a times x minus 1 times x minus 3. The b is going to be multiplied by the x minus 1 and the x minus 3. The x squared cancels out. I know that the c is going to be multiplied by x squared and by x minus 3. The x minus 1 would cancel. And finally, the d is going to be multiplied by x squared and x minus 1. The x minus 3 would have canceled out. Okay, now, once we do that, then you should be able to go in and solve for at least 3 of your variables directly. If I allow x to equal 0, and the terms I want to allow x be is any term that would cause any of these denominators to be 0. I say, well, the first two would be made 0 if I let x equal 0. Allow x to equal 0 in your equation. Your left-hand side would just be a 6. On your right, you know anything that still has a factor of x in it, it's going to be canceled out and just become a 0. So anything times 0 is 0, so the first, third, and fourth term all become 0. The only term not becoming 0 is the b. The b is going to be multiplied by negative 1 times negative 3 when x is 0. So I know b is going to be multiplied by a positive 3. So 3b is equal to 6, thus b is equal to 2. Now, in order to solve for c, you should allow x to equal 1. When I do that on the left-hand side, 9 times 1 plus 6 is where my 15 came from. On the right, once again, anything that has a factor of x minus 1 becomes 0. The only term not becoming 0 is the c. You'd have c times 1 squared, which is 1, times 1 minus 3, the negative 2. Then you can say, okay, that's going to give me negative 2c is equal to 15. Therefore, I can see that the answer for this is negative 15 over 2. Now, to solve for d, I can allow x to equal 3. On your left-hand side, 9 times 3 is 27 plus 6 is 33. On the right, anything that has that x minus 3 as a factor becomes 0. So now I'll have d times 3 squared, which is 9, times 3 minus 1, which is 2. So I have 18d is equal to 33. So we know d is going to equal 33 over 18. All I've done is I've reduced that by a factor of 3. 3 goes into 33 11 times, and 3 goes into 18 6 times. So I simplified to d is equal to 11 over 6. Now, once I have b, c, and d, it's not too hard to find a. I can't just plug some number in for x and find it though, but what I can do is I can say, please notice up here in the original expression, a would be a coefficient of x cubed. It would be a times x cubed. B would not equal a coefficient of x cubed. C would be a coefficient of x cubed. And D would be a coefficient of x cubed. Well, I'll look on the left-hand side. There is no x cubed. So we know that the coefficient of x cubed is supposed to be a 0. Now, add the coefficients of x cubed on the right and force them to equal 0 for this equation to be true. So I know a plus c plus d has to equal 0. Fortunately, I already knew what c and d were equal to, so a minus 15 over 2 plus 11 over 6 is equal to 0. I took minus 15 over 2 plus 11 over 6. Of course, I cheated and did that on the calculator. And I got my minus 17 over 3. So that's a minus 17 over 3 is equal to 0. So I know a is equal to a positive 17 over 3. Now, I take my answers for a, b, c, and d, plug it back into my original integral. I can say, well, the original integral I, we know the whole point of this partial fraction decomposition is to take a problem I could not integrate and create multiple problems I can integrate. So I've created 4 separate integrals here. The first one, a, can be factored out. You'll have 17 over 3 times the integral of 1 over x when that factors out. The next one, I'll factor out the b. 2 comes out in front. The inside would be 1 over x squared. I would rather think of that as x to the negative 2. It makes the power rule easier to do in the next step. The next term, the c got factored out. Minus 15 over 2 times the integral 1 over x minus 1 dx. I know that's just going to be the natural log of the absolute value of the denominator. Same thing in the next one. The d got factored out in front. The 11 over 6 times the integral 1 over x minus 3 with respect to x is left over. Now, all of these that have the denominator with the derivative in the numerator, we can say it's just the natural log of the absolute value of the denominator. Natural log of the absolute value of the denominator. Natural log of the absolute value of the denominator. So most of those are super easy. This one's not bad either. You just got to remember it's not a natural log function because the denominator was x squared. So now we say, well, okay, then we can use the power rule on that. X to the negative 2 becomes x to the negative 1 over negative 1. And then in my next step, I'll say, well, that negative 1 can come out and multiply the 2. And I'll get minus 2, and then that x belongs in the denominator to the positive 1 power. So you'll see my final answer for the integral is 17/3 natural log of x minus 2 over x minus 15 over 2 natural log of x minus 1 plus 11 over 6 natural log of x minus 3 plus your constant of integration. That's a gorgeous problem. Hopefully that helps you out in this section. Please let me know if you have any other questions.